All right, guys, more homework due. I believe this is due also on Monday, the 26th. Using related volumes. This particular question is basically applying somewhat of a 3D version of Cavalier's principle. Okay, if the bases are the same, they're both prisms, but you've got one kicked over, the volumes are the same if they have the same height. It doesn't matter that you've pushed it over. So if they tell me this volume has 60 cubic units and that the base, it says prism A is a volume of 60 cubic units. Prism B has the same base area and has a height, but a length but a length of 15 units on the longest edge is irrelevant. This is also 60 units. Okay, the following square base pyramid has an area of 30 square units and a volume of 96 cubic units. The cone has the same base area and height. If the area of the base, even though it's a different shape, they're telling me that square or rectangle has the same area as that circle, and that pyramid has the same height as this cone. If that's the case, they have the exact same area. It doesn't matter, the exact same volume. It doesn't matter that the shape is even slightly different. So here we go again. Pyramid A has a triangular base which measures 4 units on each side and a volume of 36 cubic units. Okay. Pyramid B has the same height, but each side of its base is 6 units long. Okay, so these are not going to be identical. They're both pyramids. They want to know the volume of this one. Okay, well, I'm probably going to need to copy this one. There's going to be some writing that's got to be done here. This one's a little bit harder. That's not what I wanted. Okay, let's get rid of this and that. Okay. So, what we know, and I'm going to go back because I should have copied it, but I didn't. It tells us that this first one has a volume of 36 cubic units. So this one is 36 cubic units. Units cubed. Well, what's the relationship here? Well, this area, how much bigger is it going to be than this area? Well, the ratio of their sides is 2 to 3. But the ratio of their areas is going to be 4 to 9. Because area is a square of a length. So like if you think about the area if you think about this in terms of a box, if I had one box where this was 2 and this was 2, and another box where this was 3 and this was 3, the ratio of their sides is 2 to 3, but the ratio of their areas is 4 to 9. Okay, so I have some unknown h. Okay, so I took the area of the base, which we don't know what it is, and I times it by some h, and I got 36. Right, that's what we know happened. Well, how is the area of the two bases going to relate? Well, this base, this one, if they're in a ratio of 4 to 9, this base will be this one times 9/4. So really what we're going to do is we're going to take 9/4 of the area of the base times the height. Now do not know exactly how Saul talked about this, but I think this is the best way. These are related areas. So basically what you're saying is, if I want to turn this one into this one, like if this was, if I want to, this is the 4 and this is the 9, I want to turn it, I have to multiply, multiply by the 9/4. So now I'm going to take 9/4 times 36 to get my new answer. And so I'm going to get 81. So it's 81 cubic units. All right, last one. This is going to be that same idea again. By the way, that last one was fairly difficult. The following rectangular pyramid has a height of 2 units and a volume of 18 cubic units. The oblique rectangular prism has the same base and the same height. Well, if it has the same base and the same height, you took 1/3 of this to get this. So if they're related, you took 1/3 of the prism to get the pyramid. So if this is 18, you got to multiply it by 3, 54. All right. That one's got a little bit of toughness to it. Don't be afraid to ask if something doesn't make sense.